Hey everyone, it is office hours. What questions do we have? It is time to do some work. Got 3 people watching. Drop questions in the chat if you have it. What chapter should we do? What concepts should we review? Mumot is currently awake. What questions, what concepts, what shall we do? You name it, we do it. Who's got the questions in the chat? Surely somebody. What should we do? We do some chapter 5. What should we do? Drop a question in the chat. Hi, Brian. Could you possibly go over finding percentiles on a standard normal curve? Yeah, or over a certain standard deviation? Sure. Let's talk about this down below. The percentiles. How to find percentiles. Good to see you, Jack, in the chat. So 213. Let's go do it. This is chapter 5. Finding percentiles on the normal curve. Okay, so percentiles on the normal curve, what are they? Percentile means area what to a point. Percentile means area what to a point. When you think about percentile, it always means area what to a point. So you think about the normal curve, and a percentile means area what to a point. I drew a leg. Percentile means area what to a point. There we go, there we go. Well, kind of. If we say that this, and we'll draw some lines. Think about, I'm looking for one word. Percentile means area what to a point. The percentile. On the test, would you rather be in the first percentile or the 99th percentile? The first or the 99th? Which percentile on the test would you rather be in? Which percentile on the test would you rather be in? The first or the 99th percentile? The 99th. That means you're over here. It means you'd probably be right about over here. So that means 99% of people scored where to you? If you're in the 99th percentile, it means 99% of people scored where to you? 99% of people scored where to you? 99 scored below. Exactly. That's what we're looking for. Great job, Jack, right there. We're looking for 99% of people scored below. Joshua, good to see you there. And so now we think about this right here. We can figure out percentiles by using the following method. Percentile, we go right here and we go 68, and that's the first number on the empirical rule. And if this is 16, we've literally figured out that this is the 16th percentile, because 16% of data is below that point. What percentile is over here? And you have to use the idea of adding up the values below it. What percent of data is below this point? Add up this number, then add up this number. The percentile right there is the what percentile. The percentile right there is the what percentile. What percent of data is below that line I just drew? Well, you can also say if 16% is above, what's below? What percentile is this? You're at the what percentile at a z-squared, the 84th, yes. What percentile is the middle of the curve? Well, I'll solve that one. We all know this, right? 50th percentile. And now, as you go higher, you get to the higher percentiles. And as you go lower, you get to the lower percentiles. And over here, we can figure out if 2.5% is above here, what percentile am I at right here? Who knows if 2.5% is above here? You can subtract from 100 to figure out the percentile. What percentile is this? On the right side of the curve is the what percentile. Because if 2.5% is above here, what is the percentile? The 97.5th. Great job, Simon, right there, the 97.5th. And for the other side, when we do percentile, it's just the amount below. And then we do 99.7. And then over here, we do the 0.15. On the top end of the curve, what is the percentile? On the top end of the curve, what is the percentile? On the top end of the curve, what is the percentile? It's the what percentile. Because there's only this little sliver above it, that tiny, tiny bit of the data. So what's the percentile? Who knows? Just subtract from 100, not the 100th, because the 100th would mean no data is above it. Well, it's not the 0.15. That's the bottom part of the curve. This is the 0.15 percentile. Percentiles have to go up, but it's not the 99th. I haven't written the full thing yet. Good answers. We'll throw you some points. Good questions / answers. It's not the 99th. It's a little above the 99th because you have to think 0.15 is above this. So what is the percentile of this? It's the what percentile? True false chapter 6? Yeah. 99.85th. Yeah. And you can check your maths on this. We'll do some true false chapter 6 because if this much is above, then this much would have to be below. So you can just subtract. Adam sees it. Simon sees it. Jack sees it. Yep. Is that making more sense? So you can always check, like, if this much is above, this has to be below. Because if you go below it, it would be the remaining 97.5. So everyone see how to, like, kind of check these numbers when you get them. You can just go here and say if 16% is below, then you could check the math and be like, this much has to be above it. And you can just check if you go above it, you'd go across there. And the below it would be across that arrow right there. I didn't draw properly with the right color. But you can do any one of these. You could say, like, below here is 2.5. So logically above here has to be 97.5, which is if you go across this, you'd get 97.5. So you just check your numbers, make sure they add up, because when you go across the curve, you should be getting 100% if you go across the arrows contiguously. But good question. Percentile means area below. And quick question for you right here. Let me ask a quick one. Somebody scored. Here's the question. You ready? Try to answer it. Then we're going to do some true false chapter 6. Someone scored in the 99th percentile on the test. The test was normally distributed with a standard deviation of 70 and a standard deviation of 10. Their z-score is 2.33. What did they score? So their z-score. Who can answer this? Try to answer it in the chat. Their z-score, that's the big hint for this, is 2.33. And they scored in the 99th percentile. Don't go to the applet. We can solve it without it. I know what you want to do. Great. Joshua's already done it. Points in the chat. What you want to do is you want to go down here and you want to draw on the curve. That's going to be a big hint. If you put 70, 80, 90, and you do the z-scores, you can then see that the answer to the question, which we'll put in a red marker, the answer to the question is going to be about right here-ish, which means it's somewhere there and somewhere there. That's where 2.33 is at. And so you're literally going 2.33 standard deviations above the mean. So you go to the mean of 70, add to it 2.33 standard deviations times 10, and that is going to be the observation equals the mean plus, so we solve for the observation, the mean plus the z-score times the standard deviation. And does that make sense? 93.3, you got it, because they're 2.33 standard deviations above the mean. So we could give you notice the 99th percentile would be in here somewhere. That's where the 99th is. It's higher than the 97.5th and lower than the 99.85th percentile. Okay, that's got it. That's really good questions. Let's do some true false chapter 6. Quick kind of tricky question there at the end on the find the grade someone got with the percentile and their z-score. Okay, so I'm going to throw you 10 true falses right here. Gosh, can I even come up with 10? Let's try. For chapter 6. Chapter 6, true false. Let's put it in the notes. And please drop another question for us to do. So this is chapter 6, true / false. Okay. And outliers. Okay. Two more. I'm running out of questions. Let me think of other parts of the chapter. Okay. I don't know why it keeps doing that for 10. 10. Okay. First question. What do you think for the first one? What do you think for the first one? Oh, might have it all. Okay, Megan, let's see if we got them all right. So the first three are kind of the same, right? It's, it's our favorite saying, anything is possible, because when it comes to outliers and correlation, what you're looking at here is you could draw a correlation like this, and this has a correlation close to 0. You can draw around it to see R equals about 0. And then if you put a point way over here, you redraw, and it has a positive correlation, versus you put a point down here and it would have a negative correlation. So that means outliers can make a correlation positive or negative. So if outliers can make a correlation positive, true. Outliers can make a correlation negative, true. It can also make a weak correlation stronger. And it also, if you have a strong correlation, like this right here, and this has a strong correlation, notice how it's closer to 1, you could put a point down here and it gets closer to 0. So outliers can make a strong correlation weak. So outliers can do anything to correlation. That's why we say anything is possible. So all those first ones right there are true, because outliers can do anything to the value of correlation, or the mean, or the standard deviation, or the variance, or the max, or the min, or another metric I can't think of. But the outlier is kryptonite's IQR and median. That is correct right there. You are correct. Outliers do not impact the median, the IQR, the Q1, the Q3. So remember, there are things not impacted by outliers, and I say this because I used to say anything is possible, like outliers can do anything. And then someone's like, well, you said they could do anything. Can they impact the median? And I was like, nope. And then they're like, but I got that wrong on the test. And I was like, I felt so bad. So that's why I literally made that outlier kryptonite thing. So these are all true right here. Outliers can do anything to these metrics. They can't change the median or the IQR, though. They don't change the median or IQR. My hair is so... Why does cold weather make your hair staticky? I don't know. There's got to be some science behind it. The correlation between gender and weight can be measured. True or false? The correlation between gender and weight can be measured, which people have already kind of answered, but let's go into detail. And people are saying false, and why is that? It's because there's a requirement, and we'll put like the notes on here. Gender is categorical, and that's the problem. So it's that we can't do gender's categorical. So you'd be like, no. That could be an association. You can say gender and weight have an association. You can't say gender and weight are correlated, so you can't do that. If something has a correlation of 0, it means no relationship, true or false on this one. If something has a correlation of 0, so we can even add in here the fact that, and it is false, so this is false, this is false. And why is it false? If something has a correlation of 0, it has no relationship. It implies... It could be parabolic. It could be something else. It could be parabolic. So it implies... exactly, Jack's got right there. No linear. So we just know it has no linear. It implies no linear relationship. So this graphic on the bottom versus this graphic, they both have a correlation of 0. This one is random. This graphic on the other side is not random, has a very strong parabolic. We can also do sigmoidal or something. There's sigmoidal relationships. This would actually not have a correlation of 0. Might have a correlation of like 0.6, but it's much stronger than... Like, to say that this only has a correlation of 0.6 negates that the relationship is so strong. Now, why is this relationship here so strong? Because the points are so what around the form? What indicates strength, where this one is very weak? This is a weak non-existent. Why is the relationship on the right stronger than its linear idea of it? Which it doesn't really have a linear form. It has a linear form, but not well described by linear. It wouldn't be straight enough. Strength is described by how tight the points are around it. And so strength is an idea. It's not completely to do with the line. Like, you can have linear strength and you can have nonlinear strength. So the one on the left is a weak relationship that doesn't really have any strength. The one on the right is not well described by the line, so the linear strength of it is not like this would be a not straight enough relationship. This one doesn't really have a problem with straight enough. It's just so it's actually fair to say the correlation is 0. That's an accurate description of that one. The one on the right, does everyone get this? So this is kind of odd, and maybe I'm blowing people's minds here. But the one on the left, you can accurately say the correlation is measured of 0. There's no linear relationship, and there's no real relationship to this data on the one on the left. The one on the right, although it has a correlation of 0.6, the relationship is very nonlinear. So this 0.6 is not an accurate representation of the strength of the relationship. So you'd be like, I don't know if we should use linear correlation to describe this non-linear sigmoidal relationship. So you have to make sure the relationship is linear, QQ straight enough, no outliers, to make sure you are describing a relationship properly. Proper description. Okay. So the 3 conditions for correlation are shape, center, spread. What are those? The 3 conditions for correlation are shape, center, spread. What are those? I can literally hear the static in my hair. That is weird. What's shape, center, spread? It is the 3 conditions are QQ straight enough, no outliers. QQ straight enough, no outliers. What's shape, center, spread? Oh, no worries. This is an XP Pen tablet. I'll show it here in a second. XP Pen tablet. It's an XP Pen tablet, and I'm using Microsoft Word. XP. What is shape, center, spread? What is shape, center spread? Shape, center, spread is the way to describe univariate quantitative data. Shape, center, spread is the way to describe univariate quantitative data. So univariate quantitative data is described with shape, center, spread. And a huge shout out to, I think this is one of the one I'm using. It's very close to it. I do like XP Pen. I think they make a good product. And so this is maybe a different, it's got I kind of want that now. Using a different one, but XP Pen, like their products, professional tablets, and they're quite large. Like it is that large. So it's really easy to use, very easy on my eyes too. So shout out to XP Pen. Really like their products. Not a sponsored deal. The 3 conditions are QQ straight enough, no outliers, and shape, center, spread are the ways to describe univariate quantitative data, like a histogram. So shape, center, spread is a histogram description of the shape of it, the center of it, the spread of it. And so this is false. What are the 4 ways to describe bivariate quantitative data? What are the 4 ways, which is not listed here, what are the 4 ways to describe bivariate quantitative data? We've already mentioned a few of them. We didn't mention the this or this. We did mention the this and the this, and already the those. So I want you to think of them. If I say them, then it's like, what did he say? What are the 4 ways to describe bivariate quantitative? The 4 ways. That's the 5. Let's go to the 5-number summary. What are the 4 ways to describe? Well, when I'm saying the this, I'm talking about the tightness of the points. When I say the this, I'm talking about the up or down, strength, direction, form, unusual features. Nice job, Megan, right there. Because strength tells us how tight the points are. Form tells us, does it follow a line or not follow a line? Direction tells us, does it go up or down? And unusual features deals a lot with things like outliers. So outliers are unusual features, things that do not follow the bivariate trend. Like Shaq is not really an outlier in his height/weight combo because he follows the trend of like, he's a big guy and he's pretty tall. So when we say straight enough, we mean the data basically follows a linear relationship. This is true. I'm just going to throw my pen now. The straight enough condition means it basically follows a line. With the conceptual questions, those will still have fill in the blanks too. It's like Canvas content. I think you'll see it's pretty fair. Basically the same ways we ask. QQ is either passed 100% or failed as a condition completely. True or false? True or false? I'm going to go into a detailed answer. True or false for number 8? Number 8. True or false? True. Data is either QQ or not QQ. And what we mean by that is if we're doing this, what kind of graphic is this? We've drawn this one in this example quite a few times. I like to do the same example so you can remember it. So what kind of graphic is this? What do we call this graphic? This graphic is called a what? Mosaic plot, the visualization of two categorical variables. So we had, did you study? Yes, no. More mosaic. Thank you, Mebot. It's a mosaic plot. And did you pass the test? So did you pass the test? Did you study? Yes, no questions. Mebot, chill out, man. We got to put you on a timer on that one. And a scatter plot is the visualization of two quantitative variables. If you have two quantitative variables, you're making a scatter plot. If you don't have two quantitative variables, you're not making a scatter plot. So if you have something like height and weight, which are both quantitative variables, unless you do height as groups. If I do heights as groups, as in short, medium, or tall, what kind of graphic would I make if height is done as short, medium, or tall, and then we look at the weights of individuals? We have three groups now. So now we've changed it so that it's categorical on the bottom. What kind of graphic do we make? Who knows? The answer is here on the screen, not... What's up? The answer is... The answer is here on the screen now. So Joshua, good answer. A stacked bar chart is for two categorical variables. So you see it's behind me right now. A stacked bar chart's two categorical. So remember I said height is going to be short, medium, or tall. So that's a categorical X, and Y is quantitative. So take another guess right there. We'll throw you some points. X is categorical, Y is quantitative. So you have to go to the X is categorical and the Y is quantitative. So what would be an answer? What would be the visualization? Side-by-side box plots. Let's take a look. It'd be something like this. There we go. Side-by-side box plots are the visualization of a categorical X and quantitative Y. So if you don't have two quantitative variables, you're not doing a scatter plot. There's no like, am I kind of doing it? Tell me, do we pass QQ straight enough for this condition? Do we pass straight enough? Graphic on the left, graphic on the right. Do we pass straight enough for the graphic on the left, graphic A? Do we pass straight enough? There's the line. I can put a line through it. Do we pass straight enough? Here's the graphic on the right. Do we pass straight enough? On the left, even though you can put a line, you do not pass straight enough. Now the graphic on the right, so this is a no way. Does everyone get like, you can be like, no way do we pass. And then on the right, I like it, this, because it did the emoji. This is like, yes, kind of. I would say 80% of statisticians agree on this one. You're going to get a lot of agreement. 100%. If someone disagrees, then they don't know stats. This is kind of, it's got some problems. You see, if you start to make it more, then it's going to drop to like 70% would agree now. Like 70% are going to agree right now. And then you start to do this like this. Now you're going to get to even more disagreements. So now even more would be like, this is the amount that agree on the answer. And now it's like maybe a 50-50. But then if you start to switch it even to where it gets worse, you could start to make it like worse, where it looks even more nonlinear. And now you're going to get the agreement on no going up. Does everyone understand what I mean by this? Is like now you're going to start to see more and more people say this should not be, we should not use it. And now you're going to see like a strong agreement on no, this is not linear. So you can see, I can rewind time now to where it's like 60% would say no right now. And then here you're maybe at a 50-50 where half say no, half say yes. People are kind of like, I don't know, maybe I don't know. And then you start to have where it looks more linear and 70% are saying yes. And here's where it looks pretty linear and like 80% are saying yes. So as it gets less and less linear, it starts to go down. Does that make sense? Like, I think that's kind of neat. I kind of like the animation of this. It's kind of a fake animation. But you can see right here where most people are going to say yes, and then it's going to start to get worse and worse if we pretend like it's a different data set. Yeah, so it's a subjective measure is what I'm getting at. On the exam is whether or not is straight enough going to, yeah, it should be very clear. Yeah, we'll do the pretty much, probably this is more than 90% now, probably 100%. We do the pretty more obvious cases. QQ is the only one where there's no in between on QQs. All right, good to see you there. And then outliers are subjective too, to where we could do the same sort of graphic where we can move a point further and further and further and further and further away. How do you know if something is an outlier? And then we'll do the last ones right here. How do you know if something is an outlier? In correlation, outliers are what? Things that do not follow the what? In correlation, outliers are what? And then we'll do question 9, 10. Outliers are things that what? Outliers are things that do not follow the bivariate trend. So that's a huge outlier. So that's a huge outlier. Ridiculous. Big outlier. Moderate outlier. Mild outlier. Not an outlier at all. Mild outlier. Moderate outlier. Major outlier. Extreme outlier. Ridiculous. The further away you go from the bivariate trend, which is the line, the more of a bivariate outlier it is. Like that's mild, moderate, major, extreme, ridiculous. The words are all subjective. It's just obviously the further out you go, you could almost do an elliptical circle of like minor, more extreme, and like ridiculous. And we do have ways of quantifying this in statistics with things like leverage. Well, leverage is one. Influence. So we do have ways of quantifying. But think of like an ellipse going out from it. Does that make sense? If you want to get really specific, you have to go into the eigenvectors. Think of the eigenspace. We're not going to do that. We're not going to do matrix algebra here. But in a sense, it's built from that. And the who follows me right here, that the extent to which something is an outlier depends on, and technically we shouldn't include that, but the further out you go in this sort of space, not the... we shouldn't have anything right here, though, because if it's on this, that's not an outlier. So this is not perfectly drawn. But it's the idea. Does that make sense? How are people doing on the idea of outliers? That it's something that does not follow the bivariate trend. The bivariate trend. A time plot is a special case bar chart. Is that true or false? A time plot is a special case bar chart. True or false? A time plot is a special case bar chart. True or false? False. A time plot is a special case what? A time plot is a special case what? Time plot is a special case what? We're in chapter 6. Scatter plot. That is false. Last but not least, to visualize two quantity variables, we will make a mosaic plot. That is false. Scatter plot. Could be a time plot, but scatter plot. So this is false too. Okay, nice job, Simon, right there. What should we do? We got time at least for one more, and thank you, everybody. We've done a lot of work today already. I'm going to do something real quick. I've been kicking this thing. I need to move it. I knocked this over, and then I started kicking it around. Okay. Okay, there we go. Good. Hard version of the Applet problem, okay? There we go. Let's get the apps going here on the screen. Chapter 5, tough questions. Applet problems. Okay, I'm going to try to stump you right here. I'm going to try to come up with a really difficult one. Okay. Really tough. I feel like you can get so good at these, you just see the answers. Sometimes they're so obvious. It's like, well, that's easy. Okay. I'm going to try to come up with a really difficult one, Joshua. Let me think. Okay, I got one. I have an idea of how I'm going to do it. So, got it. I'm drawing the thing right now. I need to draw. Make the numbers nicer. Test scores are normally distributed. So you can write this down as I say it. Test scores are normally could have made it harder. I'm going to try. Okay, what percent of students make below an 85? You might get this instantaneous. If you get this instantaneously, you're really good. Okay, so what percent of students make below an 85? Who's got it? You might get it really quick. I should have made it more difficult. I have another idea how to make it more difficult. I'll do another version. Another way. Is it? So let's take a look. You ready? Good ideas. Zariah, I think Zariah has it. Zariah, 5,000 points. So let's take a look here. What's the first thing you do on these questions? First thing you do is what? First thing, you get a question like this, what do you do? Jason's got it. What do you do first? First thing you do is what? These are the steps for solving these. What's one of the steps? Find the z-score. So let's go ahead and find the z-score. So 85 is the y. We'll do a different color here. So 85 is the y. This is the mu. This is the sigma. Observation minus mean over standard deviation equals z-score. So observation of 85 minus 70 over 10 equals 1.5. Now what you notice is that's where one of these points are at. So that's this area right, that line right there is a z equal to 1.5, which is also the observation of 85. And then another step I always support doing, I think is a very important thing, is to write your numbers. So take your numbers down here and put at the center 70, 80, 90. You go 85 or 1.5. That's horrible. And if you notice, currently we see the scores marked here between what and what. This is not what the question asks. It gives you the z-scores. But currently we see the percent of people who scored between a what and what. And you can, if you look down here, you can get the answer. Currently we're seeing the scores between what and what. We're seeing between people who scored between a what and what visually. What did people, on the graphic, you're seeing the people who scored exactly 55 to 85, exactly. So this is where 55 is at. And it's a z-score of negative 1.5. So then what we'd do right here is we would say, we know that this area right here is 87%. So this is 87, leaving a remaining, if we go right here, this would be 13% on the outside. So that's 13%, leaving 6.5 on this and 6.5 over here. So how do you get the answer? Good answer, Joshua, right there. So how do you find the area below the line? So how do you, and now you can kind of see it if you, exactly. Yep. Good answers, Ava and Jason. Good practice. That's how to do it right there. Or you could also do 100 minus. You can take the 100 minus. Does that make sense? So there's a lot of ways to solve it. You could just say, well, we want the area below. So 100 subtract from it the percentage. So with this in mind, let's try another difficult one right here. We got time for a few more. Let me try this one. Okay, let's try this. I'm trying to think of a really tough one. Okay, I got a good one. Okay, same idea about people taking a test. You score in the 70th percentile of this test. What was your test score? You score in the 70th percentile of the test. What was your test score? So maybe I can rewind time enough. You score in the 70th percentile of the test. What was your test score? There's the graphic. Okay. Solve it out. You score in the 70th percentile. Let's start on some 5,000 points for being here. You score in the 70th percentile. What is your test score? So if you have your percentiles written below on the curve, you can kind of figure out where it's at. I'm going to show you some what I would do right here. Is because we know this is the 50th percentile. According to the empirical rule, we know that 16% has to be above here, making this the 84th percentile. And then 16% has to be below here, making this the 16th percentile because 68% is between -1 and 1. So this is the 16th percentile. Yeah, you got it. Nice job, Megan. Megan got it. Megan, 5,000 points again in the chat. You are correct. That is the right answer. So with this right here, we are currently seeing the z-score of the 30th percentile. Does that make sense? We're seeing the z-score of the 30th percentile. If you try to figure out where this is at, you can put the mean and standard deviation on the curve and go 70, 80. Now, what did we just learn? With what we have down here with these scores, we're trying to find the 70th percentile. And what did we learn? What did we learn about the answer? What have we now learned about the answer? We have learned this about the answer. We know what about our answer? What do we know about it? Just by visualizing it. By visualizing it, we're like, okay, we know this now. What do we know from like visualizing it right there? We would know for certain what? And I'm looking at that. What is, you are above the mean, true, keep going. Because these are the scores. This is the actual data, not the z-scores. So this is what we know. We now know the answer must be between 70 and 80. Does that make sense? We know it above the mean. It has to be between 70 and 80. It could be that you could do middle 40. So actually, that is true right there. I like what Joshua's done right there. Is let's take the information we're given and just look at it a little bit differently right here, because we're told 30% right here. So we figured this out. We know where the percentiles are at. We've got a guesstimate now. So we are told 30%, and 30% is below here. And then if you go to right here, same side of the curve, got to move it over a little bit. Want to go symmetrically, then this would be 30% over here. And there's 40% in the middle. And check it out. What does it mean? Because it's just symmetric. You're just symmetrically going to the other side of it. What does this mean right here? Why am I highlighting this? Below this point right here is what? Why am I highlighting this right here? Below this, or to the left of this point is what? What am I trying to demonstrate for you? Well, and keep asking questions, Ava. And I think Zariah's seeing it right there. And so this is where we're going to talk about where the -0.52 helps. Because what we know is, we know the z-score. The question gives us, I should have scrolled up a little bit more. Oh, wait. Did I not put the -4.5? Oh, there it is up there. Why did I miss that? This is the z-score. Z equals -0.52. So where would the z-score be over here? For the top 30%, where would it be compared to the bottom 30%? What would be the z-score of the top 30%? What would be the z-score for the top 30%? So if the bottom, and we can make our answer easier. I'm going to do something in this question. This makes life way easier. It'd be 0.52. It'd be or I made it easier. I changed the number because now the math is easy. Because the answer is, so pretend these are the numbers now. Just pretend the question says to you it's -0.5. Well, if this is -0.5, then the positive version would just be +0.5 on the other side for the top 30%. So then what would the answer be down here? The answer is to go up half a standard deviation. So what is half a standard deviation when you look at the normally distributed curve with 70 and standard deviation of 10? So I've changed the question a little bit, but what's the new answer? Don't worry if you answered with the full decimals. The new answer would be what right here? What would be the new answer to the question? It'd be 75. Yep, because you go up half a standard deviation. So it'd be right here at 75. And you can see that's where it's at. It's at half a standard deviation up. And if you carry the decimal, it'd be 75.2 with the original framing of the question. Who feels like they follow this? This is probably one of the hardest versions I can give you. Like if you get this and you're like, that's easy, then amazing. What's up, Javante? From last semester, Javante, what is up? Let's throw some 5,000 points, Javante in the chat. Javante the GOAT in the chat. Hope see me around class. I saw Javante. I saw you at the beginning of the semester, right at the event. Clicked. Nice. They're learning some chapter 5 normal curve. Thank you, Javante, for your positivity. Saw you at the event when I think it was a crazy day. I think some library craziness. Man, I hate craziness. But with that, thank you so much, Javante. Can you do it where I calculate it to the 50th percentile? Well, the 50th percentile is easy. We got that one. Wasn't it, Javante, wasn't it at the event in HSS? There was like a food thing, wasn't there? Am I wrong? Am I making that up? I thought you were at it was like a study thing. It was like Writing Center did a study thing. Wasn't it? Yeah. See, I remember. Then I think you've seen you on PET a few times. 50th percentile is easy though. If someone scored in the 50th percentile, my memory's cooked too. What's the difference between a P number and a Z-score? So P means the percent. So P is probability. And Z, what does the Z tell us? Bella, good questions. What does the Z-score tell us? I could try. Zariah, maybe go into more detail. I'll try. Or swing by in-person office hours. Come up here in a little bit. I don't know if I'm saying this problem, but where we add to the 50, then add more. How many standard deviations above or below the mean is? The P is the same thing when the P people talk about. Exactly. That is the same. Yes. Mm-hmm. How many standard deviations above or below the mean something is? Exactly. And it could be above or below, though, because if I tell you, I say, this is what my teachers told me in school. They said, Brian, your Z-score on the test was a -2. What did I score? So my Z-score on the test was -2. What did I score? My Z-score on the test was -2. Good to see Didi in the chat. My Z-score on the test was -2. What did I score? My Z-score was -2. What did I score? It scored a 50. You are 2 standard deviations below the mean. You go -10 and then -10. Is that how we do math? I don't know. Sure. Let's just do it. Do it live. So you scored 2 standard deviations below the mean. And so the p-value tells us probabilities. Could you do like a full list of steps on solving these, like converting? Yeah, here we'll talk through. I'm going to talk through another one of these. That might be our last thing today. Then we're going to do some in-person office hours. And so we're going to do one more of these, and I'll try to make it a really difficult one. These have been some of the toughest versions of these. So let's save the office hours so people can come back and watch this. And let's show another really tough version. So once again, check out class. We did some easy ones. Now we're doing some really, really tough ones. Okay, and Zariah, I'll try to throw yours in here too. Let me think. I gotta come up with another crazy tough one. Okay. I got one. On the test, see, if you know how to solve these, you can sometimes just like guesstimate what you need to look at. On the test, and we're using the same test data. You got on the 95th percentile on the test. So you scored in the 95th percentile on the test with a mean of 70 and standard deviation of 10. What did you score? Who's got it? And then we're going to do the steps. And so write down these steps with us right here if you don't get it. We'll see someone solve it. And then we're going to show the steps I would do to solve this. So we're going to see someone working this through. And then we're going to look at the steps I would do to solve this. I think Ian's done it. I think that is correct. Okay, let's look at the steps. So step 1, write down everything on the curve you have. Okay, so step 1, I'd write down everything on the curve I have. Take all the information on the curve, write it down. And so what you see right here is it says the 95th percentile. We might not know where that's at yet, but this is the answer we're looking for, the 95th percentile. Great job, Joshua, too. And the answer is 86.4. So Joshua, you are correct. Let's throw some 5,000 points. Ian, very close. Just maybe a typing error right there. But I think Ian got it. And then Joshua, your answer is the actual answer. Good work. And so now we know we're looking for the 95th percentile. We're also going to write down here 70, 80, 90, 100. Now, you need to do the pro tip too. So, pro tip, test starts and do what? Someone say it, and I'll throw 5,000 points. Test starts and do what? Test starts and do what? The test starts and you do what? The test starts and you do what? You draw the normal curve. So the test starts and you draw the normal curve. So you can see right here, we did it yesterday. And so I want you to think. Now, if you're looking at this, draw the curve, draw all this out. If you're looking for the 95th percentile, it is between a z-score of what and what? The 95th percentile is between a z-score of what and what? So this is what you draw out. The 95th percentile is between a z-score of what and what? There's the percentiles below. 1 and 2. Does that make sense? Great job, Bella, right there. Between 1 and 2. So we know we're looking, and take a look. When we look at our graphic, what do we notice? Oh, not that. Got too many Word documents open. Where am I going? Oh, my gosh. Let's close out of that. Whoa, wait a minute. It's between 1 and 2? It almost looks like maybe this is where the answer is. Now, we're gonna clue in on that in a moment. So now we got a hint. We don't know this is the answer, but it's like, well, that's kind of weird that you're giving me a spot on the curve that might be related to where the 95th percentile is at. 95% of the data is below that point. Let's keep writing down test starts, draw the normal curve, and label. Make sure you've labeled it. And now we're going to put right here, this is 90% of the data. How much percent of the data is outside of 90? Total outside. Total outside. I want total first. This is not the 68-95 rule. This is 90. It's telling you 90, 10%, right? So that leaves 5 and 5. And of course, you know he's back. We love him. Tony Hawk. Tony, where you at? Tony comes in here. Come on, man. You ride the rails. You do an ollie. Boy, that's wrong. Can't have the graphic do that. Wait. No. Do it. Woo! Woo! Okay, you get it. And so ride the rails, add up to 100%. Joshua's got it right there. Make sure it's 100% when you mark your graphic. If it's not, you've done it wrong. So now think about this. What do we know about this below here? And let's do a darker color here to have it show up a little bit better. What do we know about below here? Below here is what? And we'll kind of keep that there. Below, well, you can still see it. There we go. Below there is what? Below there is what? Below that point 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 is what? Well, 5% is above it, 95% is below it, making it the 95th percentile. So we've now found the 95th percentile, but we only know the z-score for the 95th percentile. These are z-scores. So we know the z-score, z is equal to 1.64. So what does the z-score mean? It means how many standard deviations something is above or below the mean. If I told you your z-score was 1, you'd say you have an 80. If I tell you your z-score is 2, you have a 90. So all we have to do is take the formula of observation minus mean over standard deviation equals z-score. And if you can't remember the other formula, you could plug in your numbers. You're trying to solve for y. So minus mean, the mean is 70 over 10 equals a z-score of 1.64. So once again, you don't have to memorize the other formula because you can solve this out. And when you solve it, you'll times both sides by 10, removing this, times by 10. And then you'll add to it 70 plus 70 deletes this off of here, and you put plus 70 here after doing the multiplying. So what you're actually getting when you do this is observation equals the mean plus z times the standard deviation. And this equals to 70 plus 16.4, which is equal to 86.4. And if you take a look at where this line is at, it should look about there. So does that make sense? Like you want to mark all your numbers, mark everything you have. I think that's the biggest hint in there. But how are people doing on this? Does that make sense? You can plug in the numbers and algebra it out, or you can rewrite it yourself into this, that the observation equals the mean, because this is what it is. What is a z-score? It's how many standard deviations above the mean an observation is. So if you plug in the z-score, you can times it by the standard deviation and add it to the mean. And if it's negative, it'll go below the mean. But how are people feeling? A bit better. I might go on a quick walk right here between office hours. Yeah, read them carefully. There are quite a few of these. With that, I'm going to go take a walk and relax. So it's in Pirates of the Caribbean. It says, take a walk. So it's like, yeah. Then they walk to the bottom of the ocean. Go watch Pirates of the Caribbean. Relax tonight. Have some fun. See you in office hours in person. Go on a quick walk. Bye for now, everyone. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.